Alright, hello everyone. In this video, I want to go over homework question number 25. So when I mentioned in today's update that I didn't give you all the information that you needed to do the problem. So the first thing is the mass of these meter sticks. So I didn't give you the mass of the meter sticks. The first meter stick is 1 kilogram. The next one is 3, then 4, then 5, and then 1 again. Alright, so you will need that in order to work the problems. Next, we'll go over... Okay, so here where it says M stick is at. Okay, what this is asking is where is the mass of the meter stick acting on the meter stick? And if you go back to that window washer question we worked on, the mass of a beam or the lever or the object itself is always acting on the center of mass. So in this case for a meter stick, the center of mass is going to be right here at 50 centimeters. So the M stick is at 50. Just like for these other ones, it was given in centimeters, so I'm going to leave this one in centimeters. 50 centimeters, and that's the same for all of it. Now with this, you have all the information you need to figure everything else out, all the data you need. But I am going to go through this first one with you to show you what we're looking for on the assignment. So F1 is at 10 centimeters. So here, F1 I'm going to do in green. So F1 is at 10 centimeters, and this is going to be one of our support arms. Okay, one of those like a string or a rope holding it up. This is F1. Okay, F2, which I'll do in blue. F2 is at 90, and this is another one of those support arms, just like in the window washer question. So F2. For F3, F3 is at 20 centimeters, and F3 is our object. So you can draw that as a box here. That one, in this case, is at 20, so that's trying to pull our lever downward. And then finally we have M stick. The stick itself is pulling downward here. So step one, I've identified all of my... Here we go. I've identified all of my given information. So next, I'm going to pick a pivot point, and I'm just going to arbitrarily choose this point here. Okay, now by choosing this point where one of my forces is at, I can start figuring out all my distances, my radius, the distance from this pivot point to each of my acting forces. So we'll start here with F1. What's the radius of F1? Well, if it's located right here at our pivot point, its radius is going to be 0. Now what about F2? So F2 located way over here at 90. We're starting at 10. So F2 is located 10, 20, 30, 40, 50, 60, 70, 80 centimeters away. Okay, then we have F3. It's at 20, so it is located 10 centimeters away. And then finally, the mass of the meter stick acting at 50 centimeters, 10, 20, 30, 40, it is 40 centimeters away. Okay, so now that I've established all my distances, I can go back and see what things I can solve for. Well, I know the mass of the stick, and I know the mass for my object at F3. So I can solve the force for those. Mass times gravity. F equals mass times gravity. So for the first one, for F3, I have 5 times 9.81, and I get 49.1 newtons. For the next one, I have 1 times 9.81, so I get 9.81 newtons. I still don't know enough information about F2 or F1. I don't know any masses or anything to calculate those forces used to support our beam. But if I look here, I can figure out my torque. Okay, so I can start working on torque now. So if this is my pivot point, I'm going to establish that torque clockwise has to equal torque counterclockwise. So if I take object F3 here, and if this is my pivot point, it's pulling down, it's going to try to rotate clockwise. Same thing for the meter stick, it's going to try to rotate clockwise. F2 is countering that, it's pulling it in the opposite direction, that's going to go counterclockwise. So what I have is the torque of F3 plus the torque of M stick, or I guess I should call this F stick, is going to be equal to the torque of F2, the one acting in counterclockwise. Torque F2. Well, I have values, or I can solve the values for the torque of F3 and the torque of F stick. So if we remember that torque equals force times the distance or the radius. Remember, the difference here is the force and the distance are not in the same direction, so this doesn't work. My torque and distance are in different directions. So for F3, I have 49.1 newtons times 0.1 meters. Don't forget to convert your centimeters to meters. I get 4.91 Newton meters. Okay, and if we go over here and do the same thing, 9.81 newtons times 0.4 meters, and I get 3.92 Newton meters. So now I can plug my values in. So F3 is 4.91 plus 3.92, and that is going to equal the torque of F2. So 4.91 plus 3.92 gives me 8.83 Newton meters is equal to the torque of F2. So I get 8.83. Okay, now I can work my way backwards. So if torque is equal to force times distance, my force is going to equal torque divided by distance. So for the torque of F2, it's 8.83. F2 is going to equal torque of F2 divided by that distance. That's going to be 8.83 divided by our distance, our radius here of 0.8. So 8.83 divided by 0.8 gives me 11.0 newtons. 11.0 newtons. Okay, so now the last step, I just need to figure out this part here. With the way everything's set up, torque is force times distance. Well, if my distance is 0, I'm not going to have any torque over here. Picking this as my pivot point, I don't have any torque. Now I have to figure out the force. There were two ways we could do it. The first we went over in that window washer question. I could pick a different pivot point and run the problem all over again, and that would give me the answers for F1. Or I can think back to a previous chapter and remember that the forces up equal the forces down when an object is not in motion or in constant motion. Okay, there's no acceleration here. In our case, the object is not moving, so the forces up have to equal the forces down. Well, what forces do I have up? I have F1 and F2. Those forces are going up, F2 and F1. And those are going to equal my forces down, which in this case are my orange here, which is F3, plus my other force acting downward is the mass of the meter stick itself. So F stick. Alright, and I have numbers for all of this. F1, I don't know. That's the one we're trying to solve. Plus F2, which we just established is 11.0 newtons. That all has to be equal to, decimal point didn't show up here. That all has to be equal to F3, which we established earlier is 49.1, plus F stick, which is 9.81. Okay, so if I run the math here, F1 is equal to 49.1 plus 9.81 minus 11. And I get 47.9 newtons. So 47.9 is the force of F1. And again, if I wanted to double check that, I could choose another location and run the numbers again, figuring out the torque for F1 to see if I got the same answer. So hopefully that clarified some things. And it wasn't really clear that these two were supposed to be supporting beams or ropes. These two in the middle would be forces acting down. If you notice in some of them, it runs the same way, but the locations might change. So just the numbers will change, but the F1 and F2 are the two supporting ropes, and then F3 and M stick are always going to be pulling downward. So if you have any other questions, please let me know. Good luck on your tests this week, and be starting the electromagnetic spectrum soon.